Alright, this is section 1.3 A, because there is going to be two sections on that. This is real numbers and the number line, but we're going to break this into a few different videos that I had made up already and just kind of discuss what's going on. First off, we learned in the order of operations that exponents are the little numbers that tell you how many times to multiply the base. For example, 5 to the third means take 5 and multiply it 3 times, which ends up being 5, 25, 125. 2 to the fifth means take 2 and multiply it 5 times, which is 2 times 2, 4, times another 2, which is 8, times another 2, which is 16, times another 2, which is 32. But again, that is what we learned in the exponent game. Squares, which is part of what we're talking about here, represent all the numbers that are going to the second power. So 1 squared is how you read it. You could say 1 to the second power, but typically it's called 1 squared. That means 1 times 1, which is of course 1. 2 squared is 2 times 2, which is of course 4. 3 squared means 3 times 3, which is 9. 4 squared is 4 times 4, which is 16. 5 squared is 5 times 5, which is 25. So again, squares are simply the specific powers that have specific powers that have an exponent of 2. I have down here that it helps to memorize the first 25 squares, but I really wouldn't worry about that because in most of the things you do with squares, you're probably going to have a calculator. I say that for the students who are going into upper level math because there's a lot of those things to worry about. But again, these squares from 10 to 25, 10 squared being 100 and so on, but these are all of these squares of numbers up to the number 25. So 625 is what 25 squared is, and so on. So if you can memorize those numbers, it does help a little bit because it allows you to kind of have a good idea on where the values should be. But again, I don't recommend it unless you're really getting into some deep math. Other than that, now that we've talked about squares, again, this talks about memorizing from the last video. But what we've learned is that a square is the value that results from multiplying a number by itself. The opposite of that is what we call a square root. Alright, so a square is what do I multiply, or what value do I get when I multiply it by itself. A square root is what do I multiply by myself, or what do I multiply by itself to make that value. So when you see the notation, this is called the square root of 36. And it means that we are looking for the number that multiplies by itself to make 36. So again, the square of 2 is 2 times 2, which makes 4. The square root of 4 means I am saying what multiplies by itself to make 4, which would of course be that number of 2. So when you're looking for the square root of 36, we know from just knowing numbers that 6 times 6 is 36. So if you were asked for the square root of 36, you would simply say the answer was 6, because 6 times 6 makes that number. Again, when you see square root, think what do I multiply by itself to get to that number. Look at some other square roots briefly and then think them out real fast before expanding to something else. If they wanted the square root of 100, you'd be able to say, well, I know it's got to be a bigger number. I know 8 times 8 is 64, so that's not it. That's not high enough. 9 times 9 is 81. 10 times 10 is 100, which is the number I'm looking for. So the square root of 100 is 10, again, because 10 times 10 makes 100. 10 squared makes 100. 225, from what I know, and I'm going to use this calculator again, it's bigger than 10, so 10 times 10 is not it. 11 times 11, nope. 12 times 12, no. 13 times 13, remember I'm looking for 225. 14 times 14, nope. 15 times 15, notice gives me my answer, and since it's 15 that multiplies by itself, that answer is 15. Square root of 9 is a small number. 2 times 2 is 4, nope. 3 times 3 is 9, so the square root of 9 is 3. Again, you can think your way through that, but the calculator is probably going to be our biggest aid in doing square roots, and I'll show you how to do that on your calculator in just a second. Sometimes what you're going to do is you're going to be asked to estimate the value of a square root. So far we've seen perfect squares, but what if we're asked to estimate the value square root of 60? And this is where we have to kind of know our numbers, which is why I said that it helps. We understand that 7 times 7 is 49, which is too low, but 8 times 8 is 64, which is too high. So we're looking somewhere between 49 and 64, And if you look, it's closer to 64, which means we can approximate it to be 8, because that is the number that makes 64. Alright? If you're looking at 130, again, looking at the squares, 10 times 10 is 100. Nope, 11 times 11 is 121. That's pretty close. 12 times 12 is 144. So again, we're looking at 121, which is 11 squared. We're looking at 144, which is 12 squared. Now we just got to say which one's closer. This is 9 away, and this is 14 away, which means that we would go with the answer of 11. Alright? If you're looking at the square root of 23, again, think of some numbers. 4 times 4 is 16, not close enough. 5 times 5 is 25. Well, we've got it in a sandwich. 16 is 4 times 4. 25 is 5 times 5. Which one is 23 closer to? 25, which means that your answer would be about 5. 50. The number that comes to mind for 50 that's really close is 49, because that's 7 squared. And then 8 squared is 64. Well, obviously 50 is closer to 49, so I would say that it's about 7. Not really worried about that one there, because really what we're about to get into is what this video is about. This section of information is about. For this lesson, you are going to need a calculator. So I'm going to begin by making sure you know how to program your calculator. Please make sure your calculators are out and ready now. It does help if you stay consistent with whatever calculator that you choose. Many teachers recommend buying a graphic calculator, but it can be expensive. If you have the money and actually are going to learn how to use it, feel free to make that purchase. My suggestion is that you buy a calculator that is within a better price range. Texas Instruments makes this calculator here, which is the TI-30XS Multiview, not to be confused with the TI-30. The TI-30 is what most parents buy whenever you send them out to get it, instead of going with them yourself, because you know what it looks like and they're just looking for a calculator. But these two are very much confused, and they're very close in price, but this calculator here has so much more power. So if you are buying one, this is the one you want to look for. Again, this calculator has lots of power and is typically found for less than $20 at stores like Best Buy, Walmart, Myers, among other bigger stores. Typically, smaller stores like a Walgreens, I remember, if I'm thinking right, Walgreens and CVS don't specialize enough to buy that calculator. So again, it doesn't matter which calculator you choose. It is the programmer of the calculator that makes it work. For your information, and you've seen it on these things so far, I will use TI calculators throughout these videos. Eventually I will remember to bring one of the graphing calculators home to record with, but for right now we're working with the multi-view calculator, but they're pretty much the same in terms of buttons and how they work. For now, let's just calibrate our programming for basic number translation. Imagine that a Spanish person, for a moment, meets a German person, and neither one speaks the other's language. So that it's hard for them to communicate if one speaks Spanish, the other speaks German, but neither one of them understands it. But it does help if they speak a common language like English, because the Spanish person can translate what they're saying into English, the German person can understand it, and I think it would help them to communicate. So in order for them to communicate, they would both have to translate their words into a common language to speak to each other. Well, numbers work the same way. Common language for numbers is decimal. Fractions can be written as a decimal, as we've seen. If we see 3/5, it means do 3 divided by 5, and notice that we get a decimal, which is 0.6. That is the common language of decimals. It also is a square root language, and you might want to get your calculator out again. I have a picture of the calculator here. On your calculator, I'm going to zoom it up for you in my own way. You see the x squared key, and that is here by the 7. If you look above the x squared key in blue, I think it's in blue on yours, it might be in green, is a small little square root. Well, mine works the same way. In my x squared key, right above it is a square root. If you want to access the small little part of that button, that means you have to hit the second or shift key in order to do that. So if I want to do a square root of 75, which you want to do right now, hit second and then the x squared key, and you see a little square root pop up, and then type in what's in it and hit enter. And notice how that can even be turned into a decimal, 8.66. So make sure you see that in your calculator before you move on. Otherwise, you're running the risk of not knowing how to do it. But again, everything can be turned into a decimal, even symbols. And the only one we're going to look at is pi. I believe this even has a pi. No, it does not. Well, too bad for that calculator. But pi can even be turned into a symbol I can show you on your own calculator. By hitting pi, it even turns into a decimal of 3.14. I think some of you remember that from working with circles. Because of this, we can compare any two numbers by simply translating them into their common language, which again is decimal. Before comparing them, let's make sure we understand the definition of greater than and less than in terms of numbers. Think about a number line from negative 10 to positive 10. So we've got negative 10, negative 9, negative 8, negative 7, 6, 5, 4, 3, 2, 1, 0, and then it starts going up this way. The thing you need to understand is, in terms of all these numbers, this is the smallest number there. And notice that negative 10 is actually smaller than negative 9. Negative 9 is smaller than negative 8. Numbers get bigger as you move to the right. So if a number is further to the right on the number line, then it is bigger than the number that is further to the left. So negative 10 is smaller than negative 5 because negative 10 is further this way, which makes everything confusing for us because typically whenever we think greater than, we think in terms of positives, and we know that 2 is smaller than 4, 1 is smaller than 4 because that's how it is. But if you look at the format of numbers in negatives world, everything is the opposite. Negative 1 is not bigger than negative 3. It's not smaller than negative 3. It's actually bigger because it's further to the right. Whereas 1 is smaller than 3, negative 1 is bigger than negative 3. So what I like to tell you to do is to make sure that you start looking at those things as situations where you want to think, what do I owe? In terms of positives, you think, which one would I rather want? In terms of negatives, think in terms of what would I rather owe. In other words, how can you remember that negative 10 is smaller than negative 5? Ask yourself in terms of negatives, would I rather owe someone $10 or owe someone $5? Well, I think I'd rather owe them $5 because you don't want to owe as much. Would you rather owe someone $2 or $7? Well, I think I'd rather owe $2, which means that that is bigger because that is what you'd rather owe. So again, another way to think about that is just to kind of flip that into a question of, for negatives, what would I rather owe in that situation? Using this logic, let's compare some numbers real fast and then get ready to wrap this up and get to our video using less than or greater than or less than. Here we have negative square root of 2 being compared to negative 1.5. So what we have to do first is convert these both into decimal if they're not already. So we hit the negative key, which is below the 3 on your calculator, even on yours. So negative second x squared for square root 2 equals, and you should see 1.41. Make sure again you do that for yourself. So it's negative 1.41 here compared to a negative 1.5. And so again, now we compare unit for unit. The 1 is even with the 1, but this 4 is different than 5, so that's where we can make our decision. Keep in mind you are in negative world, which means we're asking, would I rather owe 4 or would I rather owe 5? I think we would rather owe 4 things to someone than 5, which means that this one is the one that we would rather have. And so remember, for greater than, less than, the alligator's mouth eats the one that it would rather be. And again, we would rather owe 4 than 5, which is why this is the number that we prefer. Square root of 10 compared to pi. Second square root 10, 3.16. Again, make sure you know what you're doing there. Pi, as we just saw, is 3.14. 3 to 3 is a match. 1 to 1 is a match. But 6 and 4 are different. These are positive. So it's not what would I rather owe, it's what would I rather have. Would I rather have 6 of something good or 4 of something good? And of course 6 is bigger than 4, so we want to go that way. Notice all we are doing is turning everything into a decimal. Negative 7/3 turns into negative 2.33333. Now this is awkward because both of these look the same. So when you compare, 2 matches with 2, 3 matches with 3, 3 matches with 3, and there's nothing else to compare, but we've got more 3's. Well, whenever this happens and you're behind the decimal, all you have to do is add a 0 to that number that ran out of things. Now we say a 0 compared to a 3. Again, in negative, would I rather owe nothing or would I rather owe 3? That would be the bigger number because I'd rather owe nothing, so I open the alligators to eat this number. And then the last one before we get ready to go. Square root of 1.5, second x squared 1.5, which is 1.224. 6/5, 6 divided by 5, which is 1.2. Once again, 1 compared to 1 matches. 2 compared to 2 matches. This one here, though, has nothing to compare to, so remember, because this is a decimal, I can simply add a 0, and I can compare 2 to 0. This is positives, though, which means we say, would I rather have 2 of something good or 0 of something good? And of course, I would rather have 2. So please go ahead and get your worksheet. Get ready to study for that quiz tomorrow. It is going to be another quick quiz because we've got some more computer work to do. Tomorrow we begin learning how to work through the computer and all that good stuff. So come in ready to go, and let's see what happens. Good luck. Again, put your computers up, grab your worksheets, and let's get ready to learn this stuff.